Just moves around. Yep, bigger, smaller. Smaller, bigger. Okay. Let's try this out. So, hi guys, this is a review for your your time to shine, just to make sure that we go over some basic stuff so everyone has a good shot at doing well. Okay, so here you guys can see that we are working with the point slope formula, and we're also going to look a little bit at the y-intercept slope formula. Two equations that represent linear equations, right? Lines on a graph, right? Lines. They represent the same thing. They just have some of the numbers and symbols moved around. All right, first off, let's talk about parallel lines. That's a symbol for parallel, right? You guys should be familiar with that. Two lines that don't touch. Parallel lines all have the same slope m, right? So here we have two examples. We have an equation in the point slope format where the slope always ends up being right in front of the parentheses. Okay? So that should help you find the slope. Plus it's in green here, right? Then we have another equation also in the point slope format, and its slope is also there, and it's in purple right next to the parentheses. Those have the same slope. So because they have the same slope, we could think about them like, let's see, draw a little graph. Let's see, we have that and that. And if this was my green, right, my slope, it says it's going downward, so I draw a line like this. And my purple is also going to be a line that's going downward with the same slope. So they look like that, and they would never touch. Because they have the same slope, they are parallel. Same thing for these two examples down here. Over here we have the y-intercept slope form of the equation, which means our slope is the fraction right next to the x. And over here we have our point slope form again, which means the slope is in front of the parentheses. These once again have the same slope, so they would also be parallel, just like the lines over here. So, for you guys, what slope would be parallel to y minus x equals 5 over 6, parentheses x plus 5. Find the slope parallel to that. If you said just the very same thing, 5 over 6, you got that right. What slope would be parallel to y equals 14 over 2 x plus 5? If you picked m equals 14 over 2, or even 7 over 1, which is the same as 7, you got that right. Good job. Parallel lines have the same slope. Let's go on to perpendicular lines now. This is a symbol for perpendicular. Perpendicular lines have a negative reciprocal slope. We're going to practice doing that. So for an example, here we have a point slope format of the linear equation, and the slope is always, again, the thing right next to the parentheses. So here it's negative 3 over 2. Here we have another point slope format of the linear equation, and its slope is 2 over 3. So if I take the first slope, 3 over 2, negative, and I change the sign to a positive, and I flip the two numbers, I put 2 on top and 3 on the bottom, that's our negative reciprocal, right? Change the sign and flip the fraction. That's all we're doing. And so these 2 definitely are just sign changed, fraction flipped, so they are perpendicular. Let's look at the bottom two. We have this here, this here. Let's copy down the original slope. If we flip it, we get 1 over 4. Change the sign, we get positive, which is exactly what we have right there. So both of these are two sets of perpendicular lines. Now you give it a try right here. What slope would be perpendicular to y equals 21 over 7 x plus 5? Find m. Perpendicular. If you said negative 7 over 21, which is also equal to negative 1 over 3, then you are correct. Try the second one. What slope would be perpendicular to y minus 4 equals 3 over 4 parentheses x plus 5? Find the perpendicular slope to that. If you said negative 4 over 3, then you are correct. Okay, now let's get a little more in depth with the point slope form of the linear equation, right? If we look at this here, this is telling us we already worked with the slope, we know that's there, and now we're going to work with filling in these 2 points, known points. These are given to us. Then we have our variables y and x.
Good afternoon, everybody. Just one announcement for this afternoon. We have 2 colleges visiting on Monday, Post University at 9 a.m., SUNY at Purchase College at 10 a.m. As usual, go to guidance if you wanted to partake in that. Also, have a great afternoon. There's a few backpacks that need to be picked up. And happy Halloween and be safe, people. Have fun. Have a great weekend.
Okay. All right. So known point, variables. Let's fill this in. So if we know that's our equation, we're giving the slope negative 3 over 2 and the point negative 4 comma 2. To build your equation, what do you substitute the m with? Our m is going to be filled in like so. We're going to keep the y. We don't know what y1 is, we're not working with that yet, but we know that m is negative 3 over 2. So we replace that in there. X minus x1, close parentheses. To build your equation, what do you substitute the x with? We're going to add our x now. And here x1 becomes negative 4. Okay.
Another. We have quite a few ID badges down here that were lost, and we have some candy left in the main office if you have time to come by.
Okay. Now we're going to add our y1. To build your equation, what do you substitute the y1 with? So now we're going to add our y1. Y minus, our y1 is right there, 2, negative 3 over 2. And then we're going to take a moment to look at this. Double negative means we're going to have plus 4. And that is our point slope form of the linear equation. That's it. All I have to do is fill those things in. All right.